G is the centroid of triangle ABC. We have given that AG, this segment, has 16. BD is 25. And EG, this part, has 7.5. We have to find the length of segment. And first we have to find GF. So first let me remind you what is centroid. The three medians meet at that centroid. So this is our centroid. And what is the median? Median of triangle is a segment from the vertex to the midpoint of the opposite side. So E is the midpoint of opposite side. So it means that AE is congruent to EBE. And A, next median, connect vertex with the midpoint of another side, opposite side. So again, BF is congruent to CF. And the third median, vertex with the midpoint of the opposite side. So it means that AD is congruent to CD. So now we can use congruency of medians of triangle theorem . The medians of triangle ABC meet at point G, and this theorem tells us that AG is equal to 2/3 of AF. So we have first equation, AG is equal to 2/3 of AF. What else we have from this theorem? Next, CG is equal to 2/3 of CE. And BG is equal to 2/3 of BD. First we have to find the length of segment GF. We have given AG, and we know from the concurrency of medians of triangle theorem that AG is equal to 2/3 of AF. If we have AG, so let me copy first equation. We have that AG is equal to 2/3 of AF. So we have given AG is equal 16. If we have this part, we can find AF. And if AG is equal to 2/3, it means that GF is equal 1/3 of AF. So we can write that. We can substitute AG by 16 because we have given this. 16 is equal 2/3 of AF. So now if we multiply both sides by 3/2, we will reduce this fraction. So 2 and 16 we can reduce, will be 8. 3 times 8 is 24, and this whole fraction will reduce, and I will change the sides. AF will be equal, 3 times 8 is 24. So we have AF is 24. Like I said, because AG is 2/3 of AF from theorem by concurrency of medians of triangle theorem, we have that AG is 2/3 of AF. So we can write that GF, this part, is equal 1/3 of this whole segment AF. We found AF is 24, so now we'll substitute to this equation. So we have 1/3 times 24. So this is equal 8. We found answer to question A. GF segment, GF, has length 8. Next, we have to find BG. BG, we have given that BD is 25. So again, we will use concurrency of medians of triangle theorem, which tell us that BG is equal 2/3 of this whole part BD. So let me write this. We have, this was answer to A. So now will be B. We can use this equation. BG is equal 2/3 of BD. We have given BD as 25, so we can substitute BD by 25, so this is equal 2/3 times 25. So 2 times 25 is 15/3, so this is equal 16 and 2/3. So we have BG. Now we have to find GC. GC segment, and we have given that GE or EG is equal 7.5. So let me write that. We have that we have to find GC, and we have given that EG is equal 7.5. Because from concurrency of medians of triangle theorem, we know that CG is equal 2/3 of CE. So we can write that CG is equal 2/3 of CE. So if CG is 2/3 of CE, it means that GE is 1/3 of CE. So we can write that EG is equal 1/3 of CE. So if we have given that EG is equal 7.5, so if we have EG, we can find CE. If we will have CE, we can find CG. So EG is equal 7.5. This is given 7.5. And the right side we will copy 1/3 CE. So now I will multiply by 3 both sides to reduce fraction, and 3 with 3 we can reduce, and I will change the sides. On the right side we have only CE, so CE is equal 3 times 7.5. So this is equal 22.5. We have CE. So now we can come back to our equation. If we have CE, this whole segment, length of this whole segment, we can find now CG, because CG from the concurrency of medians of triangle theorem is equal, CG is 2/3 of CE. We have CE, so now we will have that CG is equal 2/3 times CE, 22.5. So CG is equal 15. So we have C, solution to C, and now we have to find EC. And we already found that CE is equal 22.5. If we have CE, we know that CE is equal to EC by reflexive property. So we can write that D, solution to question D, we have to find EC, and EC is equal CE by reflexive property, and we already found that CE is equal 22.5. So this is my solution.